All right, let's take a look at section 11.6. It's called amortization. In the amortization chapter, we are given this formula for the present value of an annuity. And just like before, we have a major goal of filling out the formula correctly. So we do have to identify what M is. So M is 50. Let me shrink my pen. M is 50. R is 4%. T is 6 years. N is 12, right? This is all given information. And we're looking for P. Otherwise, we can plug and chug into our equation. We're going to need the multiplication of NT for our exponent, right? So that's 72. And then we just fill in the formula and try to enter it into the calculator correctly.
I always get oil in my eyes.
I'm on record. And then R is 0.04 over N, which is 12. And then we raise it to the negative NT, so negative 72. And then we divide by 0.04 itself divided by 12. So sticking this into the calculator, we have 50 times parenthesis for the quotient, parenthesis for the numerator, 1 minus parenthesis for that quantity, 1 plus 0.04 divided by 12, end parenthesis, raised to the negative 72, end parenthesis for the numerator, divide by parenthesis 0.04 divided by 12, end parenthesis, and we get a value of $3,195.87. So the present value of this annuity is this amount. Okay, let's look at this next problem. Use a calculator to evaluate the present annuity. So we're just going to do the same sort of activity, right? Okay, so we have M is $50. 1 minus 1 plus 0.06 divided by 12. N times T, this time is 60. So we have an exponent of negative 60. And we're dividing in the denominator by 0.06 divided by 12. So entering this into the calculator, 50 times parenthesis for the quotient, parenthesis for the numerator, 1 minus parenthesis 1 plus 0.06 divided by 12 in parentheses, caret negative 60 in parentheses for numerator, divide by parentheses 0.06 divided by 12 end parentheses, and we have a value of $2,586.28, and I round to the nearest cent. Then we have find the present value of the ordinary annuity again and again and again, but we're going to try different things, right? This time we have quarterly, right? So we have quarterly. So M $400 times, and I'll write it this time the way I put it in the calculator. So times parenthesis 1 minus parenthesis 1 plus the rate divide by 12 in parenthesis caret n times t. Well, n is 4. First of all, I always do that. I just get in the habit and then I forget to check myself. So at least I caught it, right? Let's go back a little because that's where the mistake was. There's no eraser function in this one. That's such a like terrible function aspect. I didn't like the red anyway, so let's start over. P equals M times 1 minus plus R over N raised to the negative NT. Then we're dividing by R over N. N equals 4 and NT equals 100. So we have 400 times 1 minus 1 plus the rate over 4 raised to the negative 100. Then we're going to divide by the rate divided by 4. Okay, so stick this in the calculator. 400 times parenthesis 1 minus parenthesis 1 plus. Oh, you're good. I was just leaning on 0.11 divided by 4 raised to the negative 100 in parenthesis divide by parenthesis 0.11 divided by 4 in parenthesis, and as a result we get the value in dollars, $13,580.42 when rounding to the nearest place value. Okay, so let's look at number 5, which again is quarterly. So not much difference between 4 and 5 actually. So I'm going to skip number 5. If you want to work through the problem, I'll write the answer down for you. Wow, whatever. I may as well just write it out, right? So M equals, or P equals, sorry, I'm stuck on the last lecture. P equals M times 1 minus 1 plus rate over N, which is 4, just like last time, raised to the negative 100, because we have the same amount of years. What changed in this one was the rate, right? So when we put this through the calculator, we get the value 5,690 and 13 cents. All right, so here's some word problems. Let's make sure we got them on the screen though. Okay, so in number 6, we have Melissa agrees to contribute $500 to the alumni fund at the end of each year for the next 6 years. Okay, so I'm just going to collect some items, right? We've got a payment of 500 every year for 6 years for a total of 6 amounts. Shannon wants to match Melissa's gift, but he wants to make a lump sum contribution. If the current interest rate is 3.5% compounded annually, how much should Shannon contribute to equal Melissa's gift? So these are the numbers that we're looking at for number 6. That's not the greatest spot. Let's try that. Okay, so let's write out our equation. P equals M times 1 minus the quantity, 1 plus the ratio, R over N, raised to the negative NT, all divided by R over N. For us, that is 500 times the numerator, 1 minus 1 plus 0.035 divided by 1. So we don't actually need that, but we'll write it there just in case anyone needs to see it. NT is 6, so negative 6. And then here divide by R over N. R over N is just 0.035 divided by 1. When you have things that are being divided by 1, you don't really have to write it. For example, right, this would be 500 times 1 minus 1.035 raised to the negative 6 divided by 0.035. And that's what we can stick into our calculator. So 500 times parenthesis 1 minus 1.035 caret negative 6 into parenthesis divide by 0.035 in parenthesis enter, and we get the value of $2,664.28. Number 7. In number 7, we have a $1 million lottery prize pays $50,000 per year for the next 20 years. If the current rate of return is 3.75%, what is the present value of this prize? Assume the lottery pays out as an ordinary annuity. So here we have the present value of annuity formula that they've given to us in this chapter, right? So we're just going to use that formula. M times 1 minus quantity 1 plus R over N raised to the negative NT all over R over N. And that's going to equal the present value, which is the question, right? So they want to know how much a regular payment of $50,000 per year. So N equals 1, right? R, I'll go back and do T. T equals 20. NT, the exponent, will be 20, right? And then we have, we could do R over R. Well, let's first do R. R is 0.0375. R over N is also 0.0375 because we divide by 1 and that gives us that value. And 1 plus R over N is 1.0375. Okay, so that allows me to write a more precise numerator of 1 minus 1.0375. That value is being raised to the negative 20. The total numerator is being divided by 0.0375. And if we stick that into the calculator, we should get how much this annuity is paying out. So 50,000 times parenthesis for the quotient, parenthesis for the numerator, 1 minus 1.0375 caret negative 20 in parenthesis, divide by 0.0375 in parenthesis. This annuity is paying out for number 7 a value of $694,810.21. So this time it's lower than the prize. Last time it was more than the prize, right? So this time it wouldn't pay to get the annuity, possibly, right? Maybe you'd rather take the lump sum if they gave you something greater than this value, for example. But the question is not, should you take the lump sum or the annuity? The question was just, what is the present value of this prize, right? So that would be the total value of the annuity at the end of the 20 payouts, right? Okay, so let's clear that out. It was actually number 6 where Shannon needed to match Melissa's gift. So I was thinking we were matching some money here, But no, that's not what was going on. We already moved on from that question. Okay, so for number 8, you look at your budget and decide you can afford $240 per month for a car. So that's going to give us, let me bust out the pen. That's going to give us an M of $240. What's the maximum loan you can afford? So what's the amount we can afford if you have an interest rate of 4% and you want to repay the loan in 6 years per month? So N equals 12, right? N times T is 72. And what else do we need? Let's see, we might need R over N. That's 0.04 divided by 12. Let's see if that's something decent. No, so we'll just leave it in fraction form. Okay, so for number 8, I'm going to use this space down here and use our formula. So for us, this is 240 times 1 minus the quantity 1 plus 0.04 divided by 12 raised to the negative 72. That entire numerator is divided by 0.04 divided by 12. And that value will be the maximum loan that we can afford, right? Because this is the amount we can afford to pay for a car payment. So 240 times parenthesis 1 minus parenthesis 1 plus 0.04 divided by 12 in parenthesis caret negative 72 end parenthesis divide parentheses 0.04 divided by 12 end parenthesis enter. I get the value in dollars of $15,340.18, which matches the answer key that I wrote down before the video. Okay. Let me clear this one out. Number 20. I recently found a real life advertisement in the newspaper. Only the phone number has been changed. Suppose that you have won $10 million lottery paid in 20 annual installments. How much would be a fair price to be paid today for the assignment of this prize? Assume the money could be invested at 9%. Okay, so what we're looking at then, let's see, got a $10 million prize. Let's first get the pen, that'll be helpful. Okay, so let's first look at what the M would be, right? So if we have 20 installments of $10 million, then that would be 500,000. So zeros cancel, and then The 2 cancels with that. And we're left with 1, 2, 3, 4, 5 zeros and a 5. Okay, check, check. I'll get rid of my scratch cancellations, but that's M, right? And then N is 1. So let's gather our components, right? N is 1. N equals 1 because it's yearly. T equals 20. So NT also equals 20, right? And then we have R, which is 9%. We have R over N. Oh, that 9 is looking awful, but I guess it looked better there. R over N is also just 0.09, and 1 plus R over N is then 1.09. Kind of crunched in over there, but let's try to put them over here instead. Okay, so in case you couldn't read my notes over there. Okay, so P is going to equal M times the numerator 1 minus 1 plus Rn, so 1.09 raised to the negative 20 because it's negative NT. And then we're dividing by R over N, which is just 0.09. So 500,000 times, no, not times, times parenthesis, 1 minus 1.09 caret negative 20, end parenthesis, divide by 0.09 end parenthesis, enter. I get the value of 4,564,272 and 4 cents. 83, 84. Okay, so how much would be a fair price to be paid today? A fair price would be this amount here, $4 million, $4.5 million. Yeah, these ones are weird because they're like opposite of the ones we had last time. This is a second example of where we had a better deal last time when we won the lottery. In this chapter, the annuity was worse, but that's okay. So these are the last two where we will be solving for P. And then just like in the last section, we can solve for M, right? So right now, our formula is such that we have, well, that mess, but we have P equals M times 1 minus the quantity 1 plus R over N to the negative NT divided by R over N. And we've been solving for P. We're going to keep solving for P a couple more times, but then we're going to switch and solve for M, right? So these are the last two problems where we solve for P, and then we're going to switch and solve for M. Okay, so let's look at finding our pieces and plugging through the problem, right? So I don't have an eraser on this one, so I'm going to have to just backtrack. suppose your gross monthly income is 5,400 and your current monthly payments are 525. If the bank allows you to pay up to 36% of gross monthly income less current monthly payments for a monthly house payment, what is the maximum loan you can obtain if the rate for a 30-year mortgage is 4.65%? Okay, so we've got some work to do. I'm going to list some of our parts out. M is going to be the one we have to figure out, I think. So let's look at what we have. We have a paycheck, right? We have an income of 5,400 and 36% of our income is 0.36 times 5400. So first we need that number. So that's 1,944. So the bank is saying you can spend, you can spend up to 36% of your income on housing, but you're also already paying 525. So you have to consider that. And so you can't use a whole 1,944 for this house payment because you have to consider the 525, right? So we can take 36% of our income less the current monthly payments to pay for the house, right? That's what we're looking at here. So 1944 subtract 525. That gives me a value of 1419. That's M, right? So our mortgage payment, our monthly house payment, right? That's M. That's going to be this 1419. Okay, so we had to do some work to get that one. And now we can kind of pick up the rest of our stuff. We have an N of 12 because it's monthly, right? We have a 30-year mortgage that we're going to consider, right? That makes NT, which I don't want to crowd my space too much, so I'm just going to back up. That makes NT 360, right? We have a rate, they told us, of 0.0465 in decimal form. And then we just enter it into our calculation, right? 1419 times the numerator 1 minus quantity 1 plus R over N raised to the negative 360 exponent. Divide that numerator by the rate divided by N, and that will be the that will be the loan, right? That will be the loan amount that we can take out. Okay, so let's take a look. One, 1419 times parenthesis 1 minus parenthesis 1 plus 0.0465 divide by 12, in parentheses, caret negative 360, end parenthesis, divide by parentheses 0.0465, divide by 12, end parenthesis, end parenthesis. Mm. And I'm not getting the answer that I wanted. So let me investigate here. I'm going to clear it. Suppose your gross monthly income, right? So income is 5,400 and your current monthly payments are 525. If the bank will allow you to pay up to 36% of your monthly income less. So let's try to subtract that first, right? So let's subtract the 525 first. Actually, so income less your payments. Okay, so I don't see anything else I could have done wrong. I did not get the answer I was expecting. So I'm going to try this and see if I do get the answer I'm expecting. So income less payments for the month would be this amount of income then that they would allow us to take 36% of, right? So I'm interpreting it this time as 36% of income less that payment thing that we have there, which gives me 0.36 times 4875. So 0.36 times 4875. This time we have 1755 to use as an M. So we're going to use M equals 1755. And I think that's probably the mistake that I made because that already sounds better to me. Okay, so let's take a look then. Because the other one was a pretty low mortgage payment, to be honest. This one's more realistic of a mortgage payment. Okay, so what we do have then is our formula, P equals M times the numerator 1 minus the quantity 1 plus R over N raised to the negative NT all over R divided by N, which for us looks like this time around, which I think that this is the right thing. Don't want to get too confident, but I think it is. So here we had a little r of 0.0465. I need to recover some of my info here. Divide by 12. Then we're going to raise that to the negative 360, right? Because 12 times 30 is, let me do it in the calculator, just in case that was my mistake. Yeah, that's 360. Okay, and then we're going to divide by 0.0465, which itself is divided by 12. And okay, I'm feeling confident. 1755 times parentheses 1 minus parentheses 1 plus 0.0465 divided by 12 in parentheses caret negative 360 in parentheses divide by parentheses 0.0465 divided by 12 in parentheses enter. Boom, bam. Okay, this was the number I was expecting. So definitely, it's always good to make mistakes and fix them, right? Not only does it feel good, right? But you learn from making mistakes. It's trial and error. And sometimes if you don't get it right the first time, you just scratch the whole thing, start over, and take another attempt, right? It took us 2 attempts, us, I share that with you. It took me 2 attempts, but at least we got there, right? In the end. So snapshot this or screenshot it. This is the appropriate way to do number 10. Okay, now let's see what we have going on for number 11, because that was challenging. I thought we were almost to the end, and then they started throwing like curveballs at us. So number 11, let me cross 10 off my list. Number 11, the McBirdies have $30,000 in savings to use as a down payment on a new home. They also have determined that they can afford between a $1,600 and $2,000 per month for mortgage payments. If the mortgage rates are 11% per year compounded monthly, what is the price range for houses they should consider for a 30-year loan? Okay, so we have to consider 2 problems because we have a low range to a high range, right? And after we find P, we're going to have to add the down payment to it. So I'll call that P1 and P2 because we have an M1 and an M2, right? Because they have this range going on. So let's first find these 2 different P's, and then we'll add the down payment to it. P is just the amount these people are looking to finance, right? So the rate is 11%, so 0.11. T is a 30-year loan. That's pretty standard for a house. N is 12 because we're dealing with something monthly. And T is 360, just like the previous problem. And we'll go about looking at the low rate first, right? So if we have 1,600 times 1 minus parenthesis 1 plus rate divide by 12 raised to the power negative 360 divide by rate, which itself is divided by 12. Then we'll have our P for the low end, the amount we want financed, right? So 1,600 times parenthesis 1 minus parenthesis 1 plus 0.11 divided by 12 end parenthesis raised to the negative 360 end parenthesis, you're ending the numerator, divide by parenthesis for the denominator 0.11 divided by 12 end parenthesis for the denominator, end parenthesis for the quotient, and we have a P1 value of 168,010.15. But we have a down payment of 30, right? So P1 plus 30,000 is going to raise this to a 9. So our low end of houses, right? I'm going to write it up here, 198. Oh, I can't erase on this one anyway, so that doesn't really do me any good to do that. But I'll try to write up at the top of the screen to get our P2, right? So let me try it. So our P2, which is our high value, will take the high end of the monthly payment they think they can afford. And then the rest of it's the same, right? Nothing changed except for the amount these folks can spend, right? Okay, let's pop out of P2. 2000 times parenthesis 1 minus parenthesis 1 plus 0.11 divided by 12 in parenthesis caret negative 360 in parenthesis divide by parenthesis 0.11 divided by 12 end parenthesis enter. I get a value of 210,012.69. But again, we want to add their down payment to this, right? So we have a P2 plus down, which would raise this to, I can't erase on this one, I'm sorry, but I'm going to write it here where I can see. This brings us to a 240,012.69. So our high, or so the amount of house that these people can afford ranges from this value to this value. And then that's the end of the procedures for just solving for P. So in each one of these, we took the same formula in all of numbers 2 through 11. We took the formula P equal to M times 1 minus the quantity 1 plus R over N raised to the negative NT over R over N. Right? Now we're going to solve for M. So in problems 13 through 21, we are going to solve for M. So M, just like in the previous chapter, we just are going to divide both sides by that quotient we've been doing this whole dang time, right? So we practiced it, we practiced it, we practiced it. Now we just have to put our divide by in at first instead of M times. Did I say R divide by? P divide by. So we put P divide by this quotient instead of M times this quotient for the rest of the chapters. I mean, for the rest of the problems in this chapter. Okay, so I suppose we should just get started then. Their formula is a little differently written than mine. You're welcome to use their formula. Just like the last time, I wrote it slightly different. If you distribute what I've written, you'll get this same result. But I'm just going to go with the more intuitive approach that because we already got into the rhythm of the times. Now we just do divide by that same process, right? So 1 minus 1 plus R divide by N raised to the NT divide by R divided by N, right? So I'm using M such that we just divide by this quantity. What they've done is actually clean it up so that they do the keep change flip algorithm, and then they end up with P times R over N divided by 1 minus 1 plus r over n minus nt. I figure why flip it on ourselves just to keep the multiplication, right? I'd rather just do the division here. But it's up to you, whichever one you want to fill out. They're going to give us the same answer. 14,000 divide by parenthesis 1 minus parenthesis 1 plus 0.05 divided by 12 in parenthesis caret negative 72 in parenthesis divide by parenthesis 0.05 divided by 12 in parenthesis equal sign. That means, well, I have an answer, but I forgot the question. Round to the nearest cent, right? We're looking for M, so we're probably looking for some monthly amount. I just don't remember if it had like a word problem attached. No, just use a calculator to evaluate. So check, check, we evaluated, right? Here, we're going to do 150,000 divide by, and I'll show you what I'm typing into the calculator, right? That might make it easier. So divide by, wow, that's weird. Parenthesis, 1 minus, parenthesis, 1 plus 0.05 divide by 12 in parenthesis caret negative n times t. 12 times 25 is a 300 in parenthesis divide by parenthesis 0.05 divide by 12 because that's the denominator, in parenthesis for denominator, end parenthesis for the quotient. So that's what it looks like in my calculator, right? 1, 2, 3, 4 zeros, divide by parenthesis 1 minus parenthesis 1 plus 0.05 divided by 12, end parenthesis caret negative 300, end parenthesis divide by parenthesis 0.05 divided by 12, end parenthesis equal sign. We have an M value for number 14 of 876, rounding to the nearest cent, 89 cents. It's just a lot of calculator work. Lean into the formulas, right? You're welcome to have them with you at all times. So just write the formulas down and plug and chug the way that you have been, right? Here, find the monthly payments for the loan. We have a $400 loan for 12 months. So we have a $400 loan for 12 months. At 13%. So this is monthly. Raised to the t equals 1, right? Because 12 months. N times t is 12 times, but it's a negative exponent, right? And then, oh, I think I was doing the calculator style, so let me backtrack. Caret negative 12 in parentheses divide by parentheses r divide by n and parentheses in parentheses. So we're just in this form writing out what you actually stick in your calculator, right? You do 400, which is P. You divide it by that quotient we've been working with, 1 minus parentheses 1 plus 0.13 divided by 12 in parentheses caret negative 12 in parentheses divide by parentheses 0.13 divided by 12 in parentheses Okay, yeah. Let me clear this. Well, I shouldn't, I don't have a eraser outing it, so I cleared it anyway. But find the monthly payment for a loan. For 12 months. I mean, I got an answer. It's just not the one I'm expecting. I'm not really sure why, because I'm not really sure what I did wrong on this one. Let's see if I go slower. N equals 12 because it's monthly. It's a $400 loan. So that's the present value, I think. And I don't want to repeat myself. T equals 1. R equals 0.13, which that's not it. NT is 12, right? And then I think I'm going to end up, maybe I did multiply. Let me see. I don't think I did, but I might have, right? So 1 minus 1 plus rate divided by 12 raised to the negative 12 divided by rate divided by 12. Oh, what the heck? What number is this? 15? I think I've gotten the same answer twice, so I think I must written something down wrong. Like I think I skipped this one in my prep work. So I'm going with $35.73 because I think I just skipped writing down the answer. So using the formula to solve for M, which is P divided by the quantity of the quotient 1 minus 1 plus R over N raised to the negative NT, all over N, R over N. Sorry, I'm getting tongue-tied. Let's see. So in the calculator, we have 400 divided by 1 minus 1 plus 0.13 over 12 to the negative 12 over 0.13 divided by 12. And like I said, I get the value 3573. And just to double check, would this make sense, right? 35.73 times 12 would give us a total of $420.76. So it looks like they're charging us some interest, but we definitely get back to our 400. So I'm calling this a win at 35.73, right? I think we could probably enter it in here, right? But I haven't been entering anything in. So let's see. Because I think I forgot to write that one down. Let's see. So 16 hopefully gets me back on track here with my key. So let me clear this out. Find monthly payment for the loan, new car financing of 3.1% on a 30-month, $12,450 loan. Okay, so P is the 12,450, right? R is 0.031. Our time is kind of wonky. 30 months when there's 12 in a year gives us a 2.5. So it's 2.5 years. And N is 12 because it's monthly. N times T then should be 24 plus 6 for 30, but I'll put it in the calculator. 12 times 2.5 for 30. And then we should be able just to plug and chug, right? We're doing number 16, so I'm just using this as space. In 16, we're using the equation where M equals P divided by 1 minus the quantity 1 plus R over N raised to the negative NT divided by R over N. And for us, that's the value of 12,450, right? Not times, but divide by 1 minus 1 plus 0.031 over 12. That's going to be raised to the negative 30, which I kind of crunched myself out. But then we have 0.03 divided by 12 as our denominator. And then that's what we're going to divide by. So what do I stick in the calculator? I stick in 12450 divide by parentheses 1 minus parentheses 1 plus 0.031 divide by 12 in parentheses caret negative 30 in parentheses divide by parentheses 0.031, cut my rate off above, and then divide by 12 in parentheses, in parentheses. So good thing we rewrote it because I made a misprint there. Again, we're still just working on number 16 here. So ignore the fact that there are these other numbers around, but 12450 divide by parentheses 1 minus parentheses 1 plus 0.031 divided by 12 in parentheses caret negative 30 in parentheses divide by parentheses 0.031 divided by 12 in parentheses. Okay, now we're back on board with our answer key as well. So that's good. I guess I wrote down number 15 and I wrote the answer for number 14 and then I skipped actually doing number 15, right? So it's kind of this weird thing, but now we're back on track. So number 16 is the monthly payment for financing this new car is going to be $431.82 per month. So the trick here was in the 30 months, right? So once you get comfortable, then they're like, oh, we'll try this now, right? We'll try this weird thing now. Okay, so let's try this weird thing now on what's going on in 17. Okay, so in 17, they want us to find the monthly payment, right? Find the monthly payment. So 17, 18, 19, we're using the same formula, right? The one we've been using. That's scratch there. So we have the formula. So we have it, the M equals P divide by bracket 1 minus 1 plus r over n raised to the negative nt, and then that is divided by r divided by n, right? That's our formula. Okay, so we have a P of 504,000. Well, that's what like I said, they're going to throw us a curveball, so let's not call that P yet. So a $504,000 home bought with $20 down payment and the balance finance for 30 years. So they paid 20% of this amount already, right? So that's actually going to be P, because they're not financing the whole house. They're just going to finance like 80% of the cost of the house. And they're going to try to put the other amount down, right? Which I don't think there are enough zeros here. 0.8 times 504,000. That means they're going to finance 403,200, right? That's what they're going to finance. Now, after they finance that balance, they're going to finance it for 30 years, right? We're dealing with monthly payments, so n equals 12. N times T is 360. Our rate is 0.044. And then it's just a matter of plugging and chugging, right? I don't have an erase-r function on this one, so I can't just get rid of that. I'm better off just continuing on down the page, right? So we're doing number 17. Just keep that in mind, right? So don't look at these numbers. Number 17, we have P. That's not P. Just went through all that. P divide by 1 minus 1 plus r over n raised to the negative 360, right? The nt, and then divided by 0.044 divided by 12. That's going to give us the monthly payment for this purchase, right? So 403,200 divide by parenthesis 1 minus parenthesis 1 plus 0.044 divided by 12 in parenthesis caret negative 360 in parenthesis divide by open parenthesis 0.044 divided by 12 in parenthesis. We have a house payment for these folks, $2,019, and rounding to the nearest cent, 7 cents, right? So again, we're working on number 17 here. And that's the house payment for number 17. And that checks out on the key. So check. Just a few left, and by a few, I mean 4 that turn into 6, right? That sort of thing. So just a little longer, hold in there, hang in there, right? We're just using this formula now for the rest of it. So let's clear this and then head down to our next problem. Sorry, buddy. Just poke the dog in the mouth. Okay, find the monthly payment for the loan. A $254,000 condominium bought with a 30% down payment and the balance finance for 30 years. Okay, so just like before, we have to consider these folks aren't going to finance the whole cost of the house, right? They're actually only going to finance 70% of the house, right? Because 30% of it is a down payment. So 254,000 with the remaining 70% that isn't a down payment means that these folks are going to finance $177.80. They're going to finance that for 30 years at a rate of 3.05%. This is a monthly loan, so n equals 12, right? A monthly payment. N times T is negative 360. Or, well, it's not negative 360 here, but we use the negative NT exponent. So I just, by habit, threw the negative in there. It's just 360. And then what? I think that's it, right? Like we really can't clean it up anymore. So what we do is we take P and we divide by the 1 minus the quotient or the quantity 1 plus R divide by N raised to the negative 360 and then divide by 0.0305 itself divided by 12, right? And then we just throw this through the calculator, make sure we caught the trick correctly, and then call it a victory, right? So I should pay attention though before I start calling victories. All right, when I put that to the calculator, I get out the monthly payment of $754 and to the nearest cent, 42 cents. Right, so that's 18. 19. Let's see if there's a catch. Finance an apartment complex. Oh, dang, a whole apartment complex. Ooh la la, right? So we're gonna finance this. That's P. We're gonna divide that by 1 minus 1 plus the rate, which is divided by 12, raised to the NT, right? N is 12, like we just said. T is 20. So N times T is double with a 0, so 240, so negative 240. And then we're going to divide by 0.034, which is divided by 12. Stick this in the calculator and we get 852,000. This one was straightforward, which is weird because they like to throw curveballs at us, right? So I hope it's as straightforward as it seems. Seems as if it is because this matches the book. So 4897.59, right? So just note these ones come from the book, right? That's what this key is over here on the side. Okay, so number 20 here. What are we looking at? How much interest? How much interest to the nearest dollar would be saved on the following loan if the condominium were financed for 15 years rather than 30. Okay, so a $2,540 condominium. This is the same as above, right? So we don't have to redo this work. This is the same as number 18. So we have to redo it with 15 years instead of 30, right? So let's redo that problem with 17800, right? Because there was a 30% down payment. Remember, we did that. This time around, though, we're going to have a 1 minus 1 plus 0.0305. The difference here is going to be in the exponent, right? Because if t is half the time, then the exponent is going to be half as large, right? So 180, 15 is t, n is 12, n t, then 12 times 15 is 180, right? So just double checking the value there that we chose, and then divide by the 0.0305, which itself is divided by 12, right? Let's see what this value is, but then they asked us how much they saved or how much they would save, right? So we have to answer a question based off of the result we get here, right? So first, let's get our result. Let's see, divide by denominator 0.0305, divide by 12, and end. Here I'm getting a monthly payment of 1232.13. Now, whatever they asked us, how much interest to the nearest dollar would be saved on the following loan if it were financed in 15 years rather than 30. So I found the payment, right? I found the payment. Let's see if that leads us to something. So if I take the difference of the payments, see, and then multiply that times 12, and then times 15. Okay, let's see. I think I jumped into that question without reading it very well first, because I was like finding the monthly payment. And then I saw that they were the same there. So I don't think we were supposed to find the monthly payment here. So let me just hit clear. And then we'll look at the problem again, right from scratch. Because like I said before, sometimes you make mistakes. You have to ditch out on what you were doing and reconsider, right? So let me just look in the book real quick. We're still in 11:6. The book's not very long. So Here we go. They did find the difference between the two. Let's see. Let's see. I'm going to put that stuff back up there for a second. If we took the amount from above and multiplied that by the number of payments that they're making, which is 360, then in the end, what they're paying for the house is 271. Well, not the house, but the amount they're borrowing, 27159.20, right? So that's how much they're going to have to pay back. Now, if we take a look at the lower value that we got here, right? This one, they're paying 1232.13, and they're paying that for 180 months, right? So in this version, they're paying 221,783.40, right? So if I take the difference between those values, then we get the value of how much we save. So that wasn't for nothing, right? It was just a matter of how do we complete this now, right? Okay, so if this is the amount repaid for the 30-year loan, right? And this is the amount repaid for the 15-year loan, then what I've done here is I've subtracted the two values. That's how much the family will save if they go with the 15-year loan, right? And that ends up being $49,000, 807.80. So I'm glad that wasn't all in vain, and that we also could pull it together without having to redo all of those steps, right? So okay. Just double checking my work, making sure I didn't make any typos here. I'm about $2 off from the book, but it could be because I rounded something. Oh, yeah. I think it's because I rounded here. So the book got 49805, and I got 807, almost 809. So, oh, it says to the nearest dollar. So I would have 808 here. So I would be about $3 off on my calculation. But I think it's in the rounding that I did in one of the problems, right? Because I didn't leave anything in the calculator. Okay, so let me clear this out. I'm calling that a victory. Right? It's also a victory that they saved that much money. And now we're to the last problem. But like I said, that's deceptive because the last problem is now 3 problems. Let's really read it closely so that we don't have to do the problem twice and we're out of here that much faster, right? So suppose you want to purchase a home for $375,000 with a 30-year mortgage at 4.4% interest. Suppose that you can put 25% down. What are your monthly payments? So we'll just start with that question. We can put down 25%. So we want to finance an amount, right? Actually, let me clear out my victory smile. I don't really want, oh, we're at the end, so I can't really cut that one off anymore. So I'll just go with this, but we can afford to pay 25% down, which means we only need to finance 75% of the cost of the house, right? So we're going to ask for a loan on 75% of the house, right? So 375,000 times 0.75 equals, we're going to need to borrow $281,250, right? So we're saying, please, can I borrow this much? I promise I'll pay you back. And they're like, okay, that's fine. We're going to charge you a 4% interest rate, right? So it's actually a 4.44% interest rate. And we're like, that's cool. We're going to take 30 years to pay it off. And they're like, that's cool. You have to pay us every month though. Right? And what it turns out to is that we're going to end up paying them 360 times, right? That's what NT is. And so in order to find out the monthly payment, we have our formula M equals P divided by the 1 minus the quantity of 1 plus R over N raised to the negative NT, R all over the quotient R over N, which for us looks like 281,250 times 1 minus 1 plus 0.0444 divided by 12 raised to the negative 360 divided by 0.0444, which is divided by 12. So 281,250 divided by parentheses 1 minus parentheses 1 plus 0.0444 divided by 12 in parentheses caret negative 360 in parentheses divided by parentheses 0.0444 divided by 12 in parentheses. I get a value of $1,415.04, right? That matches the key. What's the total amount paid for principal and interest? So if we take the payment amount from above and multiply it by 360, that will be the amount that we end up paying in the end, right? Which is what they're asking in this weirdly worded question, right? Again, I use the answer from above instead of just leaving it in my calculator. And so that using the answer from above, I get this answer, right? They left it in the calculator and got 509,415.57. And so what you should do is even though I don't have an eraser, so that's my problem with this annotator. Even though you rounded here to enter it into your calculator, I don't think you should round it in your calculator. You should leave whatever they told you in the calculator. So I'll show you what my calculator says. 0.043263 and multiply that by 360. It's not fair, but that's what they're expecting to get this answer. If the bank collects this much though, right, then the bank's only collecting the 509,414, right? Not the 415. So sometimes though the code is calculated to take both answers. If it's not taking your answer based off the rounding, so this one will be correct. But then if it's not taking this answer, you're going to want to go back and use whatever was in your calculator without rounding to get the first answer, right? And use that. So it's called intermittent rounding, and you don't want to do that, basically. Okay, so what's the amount saved if the home is financed after 15 years instead of 30? Okay, so if we finance this house in 15 years, then we have, oh wait, that's not the amount we had. Let me go back. Hopefully, I don't think it will. Let's see, so I'm gonna have to redo it a little. 0.75 times 375,000 gave me 28. Oh, come on. 281,250. Right, then we're going to divide by 1 minus 1 plus 0.0444 divided by 12 raised to the, instead of 360 payments, we're going to have 15 times 12, which is 180. Right, otherwise everything else is the same. But this time we get a total payment. We'll write our answers down that we had here. I just need to get rid of some of that scratch. Right here, we'll use the books 509, 415, 57. So again, note, do not round in calculator to go on to next step, right? So just note how we get to there, right? Don't round in the 14, 15 in the calculator, just when you write it on your paper. Okay, now let's finish up part C. 281,250 divide by parenthesis 1 minus parenthesis 1 plus 0.0444 divided by 12 in parenthesis caret negative 180 in parenthesis divide by open parenthesis 0.0444 divided by 12 end parenthesis equal sign. So this gives us a 2142.93 SK, right? But I would again say do not round in calculator. But multiply by the 180 payments, right? So times 180. That means in total, these people will pay 385,727.27. So if we take this value, I'm going to use a different color. If we take the 385 away from the 509, then we'll have the difference that we're looking for, right? So we have the amount for the 30-year loan and the amount for the 15-year loan. And this value is to find the difference, right? So we're going to take 509, 415.57 and subtract 385, 727.27. And we have a glorious grand total of 688. I get 30 cents. The book's got 31, right? So I'm only a penny away from them, but it's because I didn't round in the calculator at all. If I had, I would be way off, right? And so this is our answer for part C. They saved a ton of money this time, paying it off in 15 years instead of in 30. And they're saving in finance charges, right? So that's $123 or $123,000 worth of finance charges that they're saving. So that's super exciting. All right, I'm gonna, of course, end it right there. And next time we'll do 11.7.